All right, let's do a video for the surface area for a cone, and we're going to look at here. So let's just kind of draw our cone. All right, that's what our cone looks like, and then there's maybe some new terms. The total vertical distance, so from there to there, which is like the distance from here perpendicular down, that's the height of the cone, which is an h. This slant distance, so like if you were like up here and you slid all the way down to the edge, that's called the slant height. We call that little l. And then of course this is still the radius of the cone. It is a nice thing to notice that the height is perpendicular to that base. And so those three things are related in that r squared h squared does in fact equal L squared. And so there is a relationship between the slant height, the radius, and the height of the cone. Okay, so the surface area. So the surface area is kind of easy. So what we need to say that the surface area is just the bottom, which is a circle. So that's pi r squared plus the lateral surface area. So the curved part. Okay, so let's take a look at this curved part. The curved part's where it's going to be tricky. So let's pretend I take a pair of scissors and I slice it right here, right down the edge of the cone, and then I unravel the curved part. Okay, if you unravel, so we're really looking at the net of the cone. Okay, you get something that looks like this. And now we need to think about these distances. Okay, now remember, if you sliced it right here, right, just took some scissors and went just on the cone, and you unraveled it, this distance L is this. That's L, and this is L over here. This distance here is actually the circumference of the original cone. The circumference of the original cone is 2 pi r. Okay, and what we're interested is in this area. Okay, and what you're going to notice that this area, this two-dimensional net, is the area of this curved surface of the cone, but it's actually a sector. Okay, so I'm going to take this and I'm going to extend this and make this into the new circle. Again, this is the little circle. Okay, we're not really discussing that. I want to look at this big circle. And what we remember about sector area and arc length is that those things are all related, right? Theta is to 360 as like arc length is to the total arc length, and the sector area, I don't know, we'll call that y, is to the total area, right? We said those proportions are the same. This is some angle theta, which we don't know, and we're not even going to find out. But those three things are in the same proportion. Theta is to 360 as this distance is to the big distance. This area is to the total area. And what we're going to look at is we're going to look at this. Okay? So what we're going to say is we're going to look at this sector. And we are going to use these proportions. Okay, so this 2 pi r is the circumference of this circle. That is the sector's arc length. So 2 pi r is the sector's arc length to the total arc length of my new circle. Remember, my new circle has a radius of L. Its circumference then is 2 pi L. Okay, this is arc length. For this sector, this is the arc length of the sector, 2 pi r, and arc length of the whole circle, the circumference, is 2 pi L, because L is the radius of my new circle. Okay, now I want the sector area, which is A. Okay, that's this. That's what I want. But I know that that sector area to the total area is in the same proportion. The total area is pi r squared. But the r of my big circle is L squared. Okay, now I'm just going to do some algebra, and I'm going to get a formula for this curved area. Right, so those 2 pi's and those 2 pi's cancel. And then this is 1L, and I'm going to cancel. This is an L squared, so one of those cancel. And then I'm going to take this, I'm going to say pi L, I'm going to multiply it over here, and so I'm going to get pi L times R equals A. And then if you think about what a book would tell you, pi R L. Okay, so this area, the area of this sector, is equal to the area of the curved structure on a cone, and I just showed you that it's pi RL. Okay, so then the surface area for a cone is the circle, pi r squared, plus the wall, pi RL. L is the slant height. The slant height L is in fact related to the height of the cone and the radius of the cone. Okay, now if you looked up any book or any website or any YouTube video, they're probably just going to tell you to memorize this, which is fine. There's nothing wrong with this. But here is the proof as to where the pi RL comes from. Again, I went old school and went back to sector area and arc length and set up a proportion, and I know this proportion is true for this new circle. This new circle had a radius of L and a arc length of 2 pi r, a total circumference of 2 pi L, and a total area of pi L squared. I used that proportion to find the sector area, which is the curved part. Okay, this is how you find the surface area of a cone. You can use this formula, and if they don't give you the slant height and somehow they give you the radius and the height, well then you got to come up and use this guy, and you can actually then find the slant height if you know the radius and the height. Okay, let's do maybe one quick numerical example. Okay, so let's say I know that the height of the cone is 12 and their radius is 5. Now I did pick nice numbers there, so let's find the surface area. So the surface area is going to be pi 5 squared for the bottom plus pi r, and then what's L, right? L is the slant height, but I did pick some nice numbers here because we know that the 512 right triangle has 13 as a hypotenuse. So 13 is the slant height, and we get 13. Okay, so this is just 25 pi plus 65 pi, and that of course is an exact number of 90 pi, and we'll say square inches. So that would be the surface area of this particular cone. Okay, hopefully this helps you get started on cones.